afternoon to all. Today I will discuss about the metal joining methods, unit 3. We will start about the gas welding operation, and end of this lecture the student will able to learn that different types of flames, oxyacetylene welding and cutting. What is gas welding? Gas welding is a process that melts the molten metal, and by using heating, it melts the parent metal and then it will joint. Means here by heating them with a flame caused by the repetition of fuel gas and oxygen. In case of gas welding operation, use the fuel gas and oxygen for creating the flame, and using that flame it is melted the main metal, parent metal, and after melting then they join the metal in the proper way, and after melting the metal it will joint by the after solidification. The most commonly used method is oxyacetylene welding due to high flame temperature. Means using the oxyacetylene welding, it will create the high temperature using fuel gas and oxygen gas, and it will help to melt the parent metal. Another, flax may be used to deoxidize and cleaning the weld metal. Sometimes flax also used for deoxidizing purpose. Okay, means it creates the shielding to the welding surface, and also it will help for cleaning purpose also. Flax melt and solidify forms a slack skin on the resultant weld metal. Sometimes when it will take solidification, slack also solidified, and after solidification of the flax material, it will create the slack skin on the weld metal. And in case of oxyacetylene welding, it utilizes oxygen and fuel gas to heat the metal until it is in among molten state. Here for melting purpose of the parent metal, it uses the oxygen and fuel gas and fuse the multiple pieces of metal together, and maybe with or without filler rod. Means here in case of oxyacetylene welding, using fuel gas and oxygen, it will melted different metals together, then it will be take solidification and it will be joined both the metals without use of any filler rod. Maybe we use the filler rod, or may not be we use the filler rod. Great, that operation is great for brazing dissimilar metals together. Means it will be more applicable in case of brazing operations. Means here dissimilar metals we have joined together. Another older technology that can be replaced by GTAW, means gas tungsten arc welding. Gas tungsten arc welding. That older technology will be replaced by GTAW, gas tungsten arc welding. In case of oxyacetylene welding, that is also known as oxyacetylene welding. Okay, uses oxygen gas for creating the flame. In that applications, we may not use the pressure, or maybe we use the pressure in that particular welding operations. And also sometimes we use maybe filler materials. In that operation, we maybe use the pressure or may not be used, or maybe use the filler materials or may not be use the filler materials in that particular welding operations. Now, in case of some chemical reactions of during this oxyacetylene welding, so we are seeing that chemical composition and temperature distribution in neutral oxyacetylene welding. So what happens in that particular welding operations? We seeing that in a particular hose pipe we send the acetylene C2H2, and other particular pipe we send the O2. Okay, Then gas is there, gas means acetylene and oxygen. Another torch means here that is the welding torch is there, and when coming that two gases, mixer is there. In that mixer both gases will be mixed and means combined. Then using some burning devices, then both the gases will be burnt and then flame will be started. And due to creation of the flame, that flame helps to melt the parent metal for welding purpose. Okay, that is the welding torch. Okay, that is the inner cone. That is the inner cone. Okay, and that is the outer envelope. That is the outer envelope. Okay, here we have seen that particular inner cone 2800 degree to 3500 degree centigrade heat will be generated to that particular inner cone. And outer envelope, here in middle zone we have seen that 2500 degree centigrade heat will be generated, and end of this outer envelope we have seen that 1000 degree centigrade will be generated. Okay, now actually that is the flame, that part is the flame. So in case of primary combustion, in case of inner cone, so 2/3 of the total heat will be generated, and here 2C2H2 plus 2O2 from the cylinder, 4CO plus 2H2 means carbon monoxide and hydrogen gas will be generated. In case of secondary combustion, in outer envelope, that is the secondary combustion outer envelope, here we have seen that 1/3 of the total heat will be generated. And what type of equation will be formed? 4CO plus 2O2 from here, 4CO2 will be generated. Then 2H2 plus O2, then 2H2 will be generated. Okay. And in case of secondary combustion, also sometimes it is called protection envelope. Here because CO2H2 here consume the O2 entering from the surrounding air and thereby protecting the weld from oxidation. Means here the generated CO2 here consume the O2. Okay, due to consume of the O2, due to that produced gases, sometimes it will protect the weld surface from oxidation. In case of oxyacetylene welding, we have seen that for burning of acetylene and oxygen, that flame will be generated. In case of oxyacetylene welding, due to mixture of acetylene and oxygen. Due to mixture of acetylene and that is the acetylene and oxygen. And fusion of metal will be created due to generation of the inner cone. Flame fusion of the metal will be created due to by passing of the inner cone of the flame over the metal due to inner cone, because more temperature will be created to that particular inner cone. Also, oxyacetylene welding can used for also cutting purpose also. In case of oxyacetylene welding, we have seen that in that particular welding operations, more heat will be generated. A high temperature flame from the combustion acetylene and oxygen means higher temperature will be created. Okay. We have seen that that is the actually welding torch tip. That is the welding torch tip. Okay. And here we have sent the mixture of C2 and H2, acetylene and oxygen. Okay. Now that is the filler rod. That is the filler rod. Okay. That is the filler rod. And now that is the base metal and that is the flame. And due to burning of that particular mixture gases, the flame will be created. The flame will be created. Okay. And that is the solidified and that is the base metal. That is the base metal. That is the base metal. Okay. And that is the weld surface. After welding, that surface will be solidified weld metal. That is the solidified weld metal. In case of gas welding, we have seen that now that sound will obtained by selecting proper size of the flame, filler material and method of the moving torch, means leftward welding or rightward welding. Using that things we get the very good weld using the gas welding. The temperature generated during using the gas welding near about 3300 degree centigrade. When the metal is fused, the oxygen will be taken, oxygen from the atmosphere and the torch combined with the molten metal. Sometimes using the flame, the parent metal will be melted, and due to melting of the parent metal, sometimes that parent metal reacted with the oxygen, and due to reaction, sometimes what happens, now oxides will be formed, and due to creation of the oxides, that weld face sometimes defective. Okay, and in that particular welding, sometimes we also use the fluxes for protection of the oxygen. Means if we are using the fluxes, so it will protect the oxygen from the air, and also it will protect the reaction with the molten metals also. Another common fluxes are made of generally sodium, potassium, lithium and borax. That are the primary or preliminary or common fluxes in case of welding. That will be that helps to protect the weld metal, means molten metal, from the reaction of the oxygen with the molten metal. Another, flux also applied as a paste, powder, liquid, solid coating or gas. Okay, flux can be applied as a paste or liquid or solid or gas. Okay, or coating purpose, or as a solid coating also. Types of flame. What are the types of flame? First one is the, generally three types of flame is there. First one is neutral flame. In case of neutral flame, we are seeing that acetylene, C2H2 and O2 are mixed in equal amount. In case of neutral flame, here C2H2 means acetylene and oxygen are mixed with equal amount. And bar the tip, a welding torch, then inner cone gives, generally inner cone gives the 2/3 of the heat, and whereas the outer envelope means secondary combustion, in that cases 1/3 of the heat will be generated in case of neutral flame. Carburizing flame, that is called reducing flame, means here excess amount of acetylene we have used and less amount of oxygen used in that carburizing flame or reducing flame. The combustion of the acetylene is incomplete. Here combustion of the acetylene gas is incomplete, and that show the greenish type color. Okay, and the inner cone and outer envelope means here we have seen that the combustion means it will show the greenish type color, and it will, the burning of that particular acetylene gas is incomplete between the inner cone and outer envelope, and that reducing flame will be used for welding of the aluminium alloy, high carbon steel. For that purpose we have used that material for welding. That flame also uses. Another is oxidizing flame. Okay, in case of oxidizing flame, here excess amount is oxygen and less amount is acetylene. So using that thing we used for welding of the brass. Okay, thus oxidizing flame will be used for welding of the brass. Now in case of oxidizing flame, we have seen that is the outer envelope. Okay, and that is the inner cone. Here generated temperature near about 3500 degree centigrade, that is the oxidizing flame. Means more amount of oxygen is there and less amount of C2H2. In case of carburizing flame, we have seen that is the inner cone. Okay, and here temperature near about 3150 degree centigrade, that is the inner cone, that is the intermediate cone. Okay, and that is the outer envelope. Another, in case of neutral flame, we have seen that is the inner cone. Okay, and generated temperature is 3400 degree centigrade, and that is the outer envelope. In case of neutral flame, the amount of oxygen as cylinder, oxygen and acetylene is equal, and in case of carburizing flame, the amount of oxygen is less than C2H2, means more amount of C2H2 has been used in case of carburizing flame. Types of gas welding, generally leftward welding, another is rightward welding. In case of gas welding, we have seen that is the leftward welding, means the welding torch is passed from the rightward to leftward. Welding torch, that is the welding torch. Okay, that is the welding torch. That is the filler material. Here, welding torch is passed from rightward to leftward. That is the direction of the weld. Okay. Here, welding torch with the main, if we are taken, that is the axis, horizontal axis. Okay. Horizontal axis. In that reference line, the welding torch will be kept 60 to 70 degree. That torch will be kept to 60 to 70 degree. Okay, and filler material will be kept on with reference lines or with the reference of axis line, that is the angle is 30 to 40 degree. That angle is 30 to 40 degree. Okay, that is the leftward welding. In case of rightward welding, here welding torch is passed from the leftward position to rightward positions, means that is the direction of the welding. That is the direction of welding. If we are taking, that is the axis of the weld, if we are considering that is the axis of the weld, so in that cases we have seen that the angle of the welding torch, that is the welding torch. Welding torch creates the angle to the axis of weld, that is the 40 to 50 degree. 40 to 50 degree. Okay, and here filler rod creates the angle near about 30 to 40 degree, that is the 30 to 40 degree. That is the 30 to 40 degree, that is the rightward welding. In case of gas welding, what are the gas welding equipments? First one, gas cylinders. Gas cylinder. In case of gas cylinder, pressure, oxygen, we are maintain the pressure near about 125 kg per semi square. In case of acetylene, we maintain the pressure 16 kg per semi square. What are the regulators? Working pressure regulators, working pressure of the oxygen 1 kg per semi square, working pressure of the acetylene, that is the 0.15 kg per semi square. In case of working pressure may be varies depending upon the thickness of the workpiece. Working pressure, that regulators, in case of regulator, the working pressure varies depends upon the thickness of the weld plate. Another is pressure gauge, hoses, welding torch, check valve, non-return valve. That are the main equipments of the gas welding. Now we are coming to the discussion of the different apparatus of the gas welding. So that is the oxygen cylinder. That is the oxygen cylinder, and in that oxygen cylinder one valve is there. Valve is connected in that particular position. Okay, another is the cylinder pressure gauge, means that gauge will be used the measure of the pressure of the cylinder, means what amount of oxygen staying or remaining to that particular cylinder. Okay, and another is the outlet pressure gauge, means here oxygen coming through that particular hoses, and in that time what are the pressure remaining in that particular pipe. So here we are measuring that pressure. Same thing also we also apply to that particular acetylene cylinder. Same thing here, pressure, and also here pressure regulating screw is there, and using that things we control the pressure, outlet pressure of that particular flowing oxygen through that particular hoses. Actually that is that pipe is the hose pipes, that the hose pipe. Okay, now same thing will be kept to that particular acetylene cylinder, and in case of acetylene cylinder here is valve is there. Okay, then another pressure regulating gauge is there, that is the pressure regulating gauge. Pressure regulating gauge here, that is the outlet pressure gauge, and that is the cylinder pressure gauge. In case of cylinder pressure gauge, we measure the pressure of that particular cylinder containing the acetylene. Now that is the hose pipe, and through the hose pipe we send the oxygen and acetylene to that mixing torch. Here that is the welding torch. That is the welding torch. That is the welding torch. Okay, and that is the blow pipe, and here it will be mixed. Then using some burning device, that gas will be burned. After burning, then we melted the parent metal, and then we will do the welding. Now, in case of real cases, we are seeing that is the oxygen cylinder. That is the oxygen cylinder. Okay, and that is the acetylene cylinder. That is the acetylene cylinder, and that is the oxygen cylinder. So, using that things, there are the some hose pipes is there. That is the hose pipes, and different regulators is there. Okay, and then we send the both gases, means acetylene and oxygen, and here what happens, that is the welding torch, and that is the mixer is there, and here in that chamber both gas will be mixed, and then here through the welding torch the gas will come, and using some burning device we burn the gases, and that shows the welding operation using the welding torch. Means across these positions we do the welding operation, and that is the filler material, that is the filler rod. Okay, and that flame will be created, and that flame helps to melt the parent metal, and due to melting of the parent metal the both plates will be joined. Okay, across that position. Sometimes also for joining of that particular plate we use also filler rod also. What are the advantages in case of gas welding? It is very simple. It is very simple, portable, and easily we have maintained that particular gas welding operations. Okay. What are the disadvantages? First, it is a very low welding speed. It is a very low welding speed, means that is the uneconomical. Sometimes large amount of heat will be required. Some amount of heat will be wasted, and some amount of heat will be distributed over a large area. Okay. Another large heat affected zones. Large heat affected zones will be created to that particular gas welding operations. Another, should not be used with reactive metals. That gas welding operations also we do not use some special materials like titanium and zirconium, because that materials are reactive with the oxygen. That's why we do not use that materials also. In that operation, particular welding operation, we do not use that gas welding purpose. Some other methods we have used for welding of that particular titanium and zirconium. And end of this lecture, student will able to learn the different types of flames and oxyacetylene welding and cutting. They are getting the idea about from that particular lecture. That is the principle of gas welding. Actually, that is the oxygen cylinder, and that is the acetylene cylinder, and using that welding torch across these positions we do the welding operations, and one is outside pressure gauge and other is cylinder pressure gauge. That is the regulator, and oxygen control valve is there, and regulator is there, hose pipe. That is the oxygen cylinder, and that is the acetylene cylinder. That is the hose pipe through which we have sent the acetylene and oxygen. Gas is coming and mixed in that particular mixture. And here that torch burning operations we have done, and due to burning of that particular gases, metal will be melted across that joining and do the welding operations. And sometimes we have also used the filler rod for joining purpose of the two metal, and that is the actually welding zone. That are the welding zone. What are the main equipments in case of gas welding? That are the regulator, then oxygen control valve is there, that are the regulator. Also here also acetylene control valve also there, that is the hose pipe. It is the welding torch. Actually the color of the oxygen cylinder, that is the black, and maroon color in case of acetylene cylinder. That is the oxygen cylinder, black color. Standard color is black. Pressure we have maintained for 1200 to 1400 kilonewton per meter square. 6.2 capacity is the 6.2 meter cube and mass 80 kg. In case of acetylene cylinder, the main color of that cylinder, that is the maroon. There are the cylinder valves. That is the oxygen cylinder and that is the acetylene cylinder. That is the cylinder valve, and using that valve we control the acetylene and oxygen gas. That is the oxygen cylinder valve. Valve are fitted to that cylinders using thread. That is the acetylene cylinder valve. Valve fitted to that cylinders, handed threads for cylinder, acetylene cylinder. Right-handed threads is there. And cylinder valves used to lock the compressed acetylene gases. Pressure gauges is there. That is the pressure regulator. Two pressure gauges are fitted both the cylinders. And other one will be shows the working fuel gas and oxygen. That is the oxygen valve. Another is the acetylene valve, and that is the mixing chamber. That is the mixing chamber, and that is the handle, and that is the head tube. The oxygen and acetylene in a correct proportion and burning the mixture with the presence of the air. And also this flame creates the very high temperature. In case of right ward welding, we do the welding operation from left ward to the right ward. And using sometimes we use the filler rod also. To right hand side. That is the welding direction, and that is the welding torch, and that is the filler rod. And here angle maintained across the axis of the weld 30 to 40 degree with respect to filler rod, and that angle in case of welding torch they are about 40 to 50 degree. That is the vertical welding. Here also we have used some filler rod also, that is the welding torch. And sometimes for cleaning purpose we are use some wire brush also. For cleaning of the welding surface we use chipping hammer, brush. Sometimes we use the goggles from the protect from the radiation emitted from the flames from the molten weld metal. Hand gloves also we have used from the protection of the generated heat. Metal splashes.